So we're going to start looking at limits, start maybe a little bit informally at first, and then we'll make it a little bit more formal. But basically, we're just going to take a guess of what's going on with graphs, and that's essentially what limits are. But we're using patterns to make that guess. Okay, so we want to know what's happening as to the graph as we change the independent variables, we change x. So in this case here, we have some data, but a graph, but we have some parts of this graph that are missing. Okay, so we have to make the best estimate here. So if we want to make an estimate for March, okay, so March, I'm going to do in green here. There's March right here, and we want to get an estimate for March. Well, I'm not going to estimate like 24,000 riders because that doesn't seem to be correct. Okay, now it might be the case that it's 24,000, but our best guess is probably going to be somewhere in here. Okay. So we're going to probably guess somewhere around, let's say about 7,000. Okay. The reality is, yeah, we might have had 32,000 because there's some, important event happening on the metro and the Paris metro in 2010 at March. It's a big event and there's tons of riders. We don't know. But our best guess would be there. And that would be what our limit is. Our limit, it looks like it's going towards 7,000. When we look at August, middle of August. Again, we could say that, oh, nobody's riding it because it's too hot, but that's not really a great guess. Our better guess is right here. Okay, it looks like it's headed towards that spot, somewhere around, let's say about 25,000. Okay, so again, we don't know. Maybe it was, the metro was down for a while, so we had very little ridership at that point, but we don't know. Okay, but our best guess is our limit. It looks like about 25,000. And same with November. November, we wouldn't guess, 12,000. We're going to guess somewhere around here. Okay, that's probably going to be our best guess here, about, let's say, about 32,000. Okay, and again, we don't know exactly what happened because that data is missing, but a limit is basically our best guess. And this is really what the essence of limits are. So we're going to give it some formal notation though. Okay, so limit notation looks like this. The limit as the x variable goes to some value a. Okay, what this implies is coming from both sides. It's going to a this way, okay, and this way, okay, from both sides. So we want to know what's happening to the y value as the x gets closer and closer to that x value given here. So for example, this one is 3. So if I want to know what's happening on the red curve as I approach 3, well, I'm not going to look right at 3 because I know exactly what's happening there. That's not what it's asking. Okay, the limit is not asking what's happening at 3. Okay, this is very important to understand. The limit doesn't care what's actually happening there. Okay, what it does care about is where it looks like it's headed. So as I head towards 3 this way, and as I head towards 3 this way, it's looking like I'm headed towards this point right there. Okay, it looks like it's probably headed towards, I would guess estimate to be about 3. Now, in this case, it is actually 3. But again, the limit doesn't tell us exactly what's happening at that point. It doesn't care. That's irrelevant that it's actually at 3. Okay, same with when we go to 1. Okay, as we approach 1 from this side, and as we approach 1 from this side, okay, it looks like it's headed towards about that point. Okay, so maybe our best guess would be about 7. Okay, the limit is not telling us it's at 7, it's just telling us it looks like it's headed towards 7. Now again, the fact that it is at 7 is irrelevant for the limit. The limit is just telling us what's happening, what's our best guess as we approach 7 from both sides. Okay, and the same thing here. Now, there's nothing at 2. Again, the limit doesn't care about that. And that's the nice thing about limits. It doesn't care what's happening at 2. It just wants to know what's happening as we head towards 2. So as we head towards 2, what's happening? Well, I'm headed towards 2 here. I'm headed towards 2 here. It looks like I'm hitting the value of 4. Okay, and that's the limit. And there's nothing there. Okay, at x equals 2, there's nothing there. There's a hole there. Okay, and it doesn't exist. The actual f of x does not exist at that point. However, the limit allows us to say that we are going, it looks like, although we can't get there, it looks like it's headed towards 4. And that's how we use limits. Okay, the limits tell us what's happening, where it looks like it's headed, but it's not telling us or defining what's actually happening at that point.